Number 5, we're supposed to prove that this statement is true. To do so, you just want to list a fact that relates to this problem, and then manipulate that fact using rules that have been predetermined to be acceptable. So we could start this out by saying sine of angle C over C equals sine of angle A over A. That's simply the law of sines. The reason I chose C's and A's, if you look up at what we're supposed to prove, it has C's and A's in it. So it was a simple choice for me. Looking at what we're trying to accomplish, notice that what we're trying to accomplish has all the signs on one side of the equation, all of the little letters on the other side. So let's try to accomplish that. Let's not get too greedy. Let's just go one step at a time. Also notice that on this left side here, little c is at the bottom left. Notice we already have little c on the bottom left, so we don't want that to move. It's in the perfect position. Everything else, well, that's not true, not everything else. Notice also sine of A is in the perfect position at the top of a fraction. We don't want those to move. Everything else needs to change except for those things. So let's multiply both sides by A. That's the opposite of dividing by A. And that helps us for two reasons. One, it gets rid of the A on the right side of the equation. And two, it gets A on the top of the left side. It's what we like to call a twofer. It's a twofer. Now we need to get this sine of C off the left, and specifically we need to get it on the bottom here of the right side. We can do that by dividing both sides by sine of C. If you do it on the left side, your sine of C's cancel. It gives us A over C. If you do it on the right side, you get sine of A divided by sine of C. We just divided both sides by sine of C. Let's take a gander at what we are trying to accomplish and where we're currently. We need A and C on the left, which we have, one on top, one on bottom. We need sine of A over sine of C on the right, which we have. What we need is a minus C and a minus sine of C. So how do we do that? Well, this is kind of going at this sideways. Somehow, we have to get subtraction in this problem, which clearly shows what we're trying to prove has subtraction in it. Let's subtract something. We have to subtract something from both sides of the equation that appear to be different things. On the left, it appears as though we're subtracting C. On the right, it appears as though we're subtracting sine of C. It's not entirely true. We are really subtracting 1 from both sides of the equation. Let me explain. If you subtract 1 from the left, and you're trying to subtract a whole number from a fraction, you need common denominators. So that 1 becomes a C over C. Same thing as 1, just looks differently. On the right, if you're trying to subtract a 1 from a fraction, you need common denominators. The denominator would be sine of C. Sine of C over sine of C is the same thing as 1, just looks differently. Then, to subtract your fractions, you are to subtract your numerators, leave the denominator the same. If we do that, we end up with what we were trying to prove, which means we're finished. You're finished when what you're trying to prove is exactly what you see. Everything that's on the left is supposed to be, everything that's on the right is supposed to be. The answer to this problem is not the last step, but it's all 1, 2, 3, 4, 5, 6 steps that we did. Please note also, you could have done this problem completely different than the way you just saw here, and it'd still be correct. There's not one way to do this. There's not one way to skin a cat, as they say. Seacrest out.